Okay, after we talk about population, sample, parameter, statistic, and then descriptive statistic, inferential statistic. Now the topic is talking about variables and measurement scale. This is very important thing to be discussed in this course, because to calculate parameters, statistic, and so on, you have to understand well about variables and the measurement scale of the variables. Variable defined as any characteristic observed in a study. For example, age in year, gender, male and female, profession, lecturer, for example, or doctors, weight, for example, 60 kilogram, 70 kilogram, and so on. Height, 170 centimeter, 162 centimeter. Education's level, primary school, secondary school, senior secondary school, bachelor, doctor, and so on. Okay, so if we are talking about variable, you have to understand about type and measurement scales of variable. In the next slides, we will discuss about type and measurement scale of variable. Measurement scale of a data can be divided into 4 types, namely nominal, ordinal, interval, and ratio. The meaning of nominal scale can only differentiate but cannot rank. For example, gender, male and female, and religion, for example, Muslim, Hindus, priests, and so on. With this scale, you can just distinguish between gender, male and female. You cannot say that male is better than female, as well as religion. While ordinal scale can distinguish and rank. For example, education level, primary school, junior secondary school, senior secondary school, and university. We know that junior secondary school, or SMP, is higher level than primary school, or SD, as well as SMA, senior secondary school, is higher than SMP as well as SD, right? So, the 2 measurement scale, nominal and ordinal, is many times classified as qualitative scale. An interval scale and ratio, they are quantitative scale. If interval scale can describe about interval, but doesn't have a meaning as a ratio, for example, IQ, temperature, for example, 70 Celsius grade does not mean that twice hot than 35. This difference with, for example, age and weight. If your weight is 100 or 90 kilogram, this is twice of the 45 kilogram, right? This is ratio. So we call interval and ratio measurement as a quantitative scale. Okay, there are still many other examples of every scale of data. If previously we differentiated data based on measurement scale, now we differentiate it based on data type. Based on the type of the data is divided into categorical data and numerical data. If the categorical data type can only distinguish categories, while numeric data is divided into two types, namely discrete and continuous. Take a look at the slide here. For categorical data, for example, marital status, married, non-married. Or if any question, are you registered to vote? Yes or not? Are your color, for example? And another example in previous slide, for example, education level, for example, this is also categorical data. While numerical data, discrete as a part of numerical data, for example, number of children, 1, 2, 3, 4. This is discrete. Another example, for example, for continuous is weight and voltage. If number of children, there is no 2.5, 3.5 difference with continuous. So sometimes we call also with counted data in discrete view. Okay. I hope that from this description type of the data and measurement scale, you really understand what you have if you measure of variables in a survey or in experiment and so on. Okay, so the two things are very important because the statistical method will be depend on the type of the data, will be also depend on the measurement scale. The next topic we are talking is about data and data collection method. Okay, although in the previous slides we have talked many times about data, but we haven't talked about more detail what is data actually. By definition, data are the facts and figures collected, analyzed, and summarized for presentation and interpretation. So, according to the measurement period and number of observations, data can be classified into cross-section data, time series data, panel data, and space-time data. What is difference between four kinds of the data? Cross-section is defined as several observations, but you measure just one time period. While time series data is one observation, but you measure in several and regular time periods. Panel data is several observations, several and regular time measurement period. This is combination between cross-section and time series data. Space-time data is one observation on several locations or several and regular time measurement. So, the understanding of the kind of the data, this is very important for application of statistical method, because some method will be implemented just for cross-section, another method analyze will be used to analyze time series data, another with panel data, and so on. So what is important that you have to understand about what is cross-section data, time series data, panel data, and space-time. Okay. This is example of cross-section data. Remember, several observations, but one time measurement period. For example, we have 4 districts, and then in each district will be measured 2 variables, number of population and income per capita in rupiah per month, for example. So in district A, for example, there are 1.3 million people. District B 0.9, District C and D 1.1 and 1.4. Another variable, income per capita, as you see here, 670,000 rupiah, 750,000 rupiah, 1,100,000 rupiah, and 830,000 rupiah per month. So we measure just in one time. For example, this is in 2020, for example, or 2019, for example. So that means we call this data as a cross-section data. You understand? Okay. This one we call with time series data. Remember, time series data is one observation, several and regular time measurement period. For example, in row you have year here, 981, 82 until 94. This is just for one observation. And then you have another variable. For example, here number of soul, 127, 134, and so on. Because this is just one observation, one object, but measured in several periods, so we call this data as a time series data. Take a look the table in this slide. This is example of panel data. Sometimes we call also longitudinal data. So we have n observation, and then every observation or every object measure some time, 1, 2 until t, and then we measure some variable. We call here variable 1, 2, 3, and so on. So if you have the data structure of the data like this, then we call as a panel data. So what about with space-time data? This is a little bit different with longitudinal or panel data. In the first column, this is indicate a location, not individual, but location, A, B, C, and so on, different location. And in every location, you also measure periodically or some time here. And then you have some variable. For example, in location A, in district A, for example, in year 2020, you have a data production of corn, production of rice, and then in 2021, you have also another data, corn production, rice production, and then you have also the data in district B, C, and so on. So if your data like this, so you call with space-time data. Okay. And now we are talking about how we collect the data. There are at least 3 methods how to collect the data. The first one is experiment. The second one is survey, through survey, or administrative. The data collected through experiment, meaning that the data generated giving treatment to an object. That means we can get the data if we provide a treatment to the object. Before we give the treatment to the object, the data is not available. Normally, this method is used for agriculture research or science, basic science, psychology, and so on. It's different with survey, data that collected by through the survey. In the survey, actually the data is already available in the field, in the nature. But we as researchers just collect the data. It's very different with experiment, right? Experiments data is not available before any treatment, while survey data is actually already available in the field, but we need to collect the data. So normally in the survey or survey is applied in the social economic survey. This difference with experiments. Then while administrative, data obtained from the result of administrative record of an institution, for example in the bank, the data is available without any experiment, without any survey, but the data is already prepared by institution. Okay. Let me introduce you to the meaning of the big data. These days, with the development of technology, many people talk big data. So what is the big data? Data in very large and complex. This is the definition of the big data. That means volume of the data is very huge. The size is very large. And the data has also various, many types, include text, images, sound, video, as well as velocity of the data. The data changes fast. So therefore, this data, it cannot be managed or captured, stored, analyzed with conventional database programming software and tools. In another side, from statistical side, so we need skill to data analysis, because we cannot use the traditional data analysis. So this is the real issue with the big data. So after we talk many things about type of the data, measurement scale, understanding of the population sample, parameters, and then statistic, and then form of the data, cross-sectional, time series, panel data, and so on. So in the next slide, I will just explain to you what is the application of statistics. Statistics as a science can it be applied in various fields. For example, you can see here, statistics can be applied in economic. For example, to predict economic growth per year, as well as you can also use statistics in business. In political field, for example, you still remember, of course, many survey institutions use statistics to predict the elections importance. Remember? When in presidential elections in Indonesia, many survey institutions predict who win with a quick count, remember? So another field that statistics also use is, for example, to predict climate or rainfall. So as summary of the implementation of statistics, this is many field, many researchers use statistics to analyze and to solve the issues. Thus the lecture material for the first week. I hope all of you will enjoy studying statistics. Thank you very much. See you next week. Goodbye.